Hi everyone, today we're going to look at the Click PLC HMI Rotary Encoder dial input, and what you'll see is in my diagram here you will see that we have our rotary encoder, and this is a 20 turn pot, and you can see how we can just drill a hole and we have a washer and a nut that will just attach it to our panel. And the rotary encoder actually will use two inputs to the PLC to control the rotation. And unlike a traditional potentiometer where we have a fixed spot at the end and at the start, we have an infinite turn on our encoder. So that is our encoder, and we currently have it hooked up to our Click PLC located right here, and we have our dial that we have our encoder attached to. So our encoder, this is what it looks like here, and it's a D-type housing, which we have our dial, and that will fit right onto there. So as we turn this, we get pulses coming out of our unit. So that is our dial itself. And then we have our wiring diagram for our encoder, and you can see that we have a phase on our encoder and a B phase, and we have a common for that, and they go into some resistors. These are pull-up resistors, and you see that we have our ground and we have our plus. So in this case here we're using 24 volt DC to our PLC, so you'll see that our ground or common is connected to our common here, and then we have our plus voltage. Now our PLC will act as our load that we have here, so this means that my common on my PLC side, located right here, is actually going to be plus 24 volt. Then we go through the PLC and then to the switch itself, so the A phase or B phase will then connect directly to our input. So here is an example of our wiring diagram to our click. So there's my common 1, which is connected to the plus of our power supply, and then the minus power supply connected to the common of our rotary switch, our rotary encoder. Then we have X1, which is connected to our A phase, and X2 connected to our B phase. So that is the wiring that we have. And with this encoder we also have a switch itself. So if we actually push on the end of this, there's actually a switch in there, and we can actually pick that up. In our case here, we're going to use D and E. So again, our common, our PLC is at the plus, and our minus goes through E and then D back into the input side. So that is our wiring for our unit. Then if we look at the actual sequencing, what you'll see is there's several different ways of programming this. The first thing to do is we could look at the leading edge of A and determine if B is on or off, and then the trailing edge, so we can pick up a couple of signals every time we rotate that. Or in our case, what we're doing is we're saying if A is on and B, pick up the leading edge of B and then count 1, because then we're going in the clockwise direction. And that's exactly what we're doing here in our program. So as soon as we have A on and then we pick up the leading edge of B, it will add 1 to DS1 location, which counts our rotary encoder pulses and puts it into our output channel here. So again, as soon as the next one comes in, then we have the leading edge, it will count then 2, and then we have the next one coming in and it counts the leading edge of B, that counts 3. Now going the opposite way or counterclockwise, we're going this direction, and when we do, as we get rotary encoder B on, okay, so when B comes on, we're actually then looking for A and the leading edge of A, which is here. So here we're then counting counterclockwise, or we're subtracting, in our case, 1 pulse. So again, as soon as B comes on, we look for the leading edge of A. B comes on, leading edge of A, and we can pick that up. So again, several different ways of doing this. In this particular case, this is the way I programmed our click to operate. So when A comes in counterclockwise, we look at for the leading edge of B, and it adds 1 to it. If we have B coming on, we look at the leading edge of A, and then we subtract 1 from that. So that gives us both directions on our dial. Then we look for our maximum rotary encoder pulses. In this case here, I determined that I like 10 turns on the pot, so it gives me 20 pulses per turn times 10, so it gives 200 pulses. So I look at DS1 for a value greater than or equal to 200, and if it is, I just move 200 into it so that it only goes to the maximum. Next on my program, if I look, I have my pulses when they're 0. So as I subtract them, if my DS1 falls below 0, I put 0 in. So I can't go below 0 on my pulses. Then finally we have our reset. So we take rotary switch input number 1, and we will, as soon as we hit that switch, it zeroes out our pulses. So let's just take a look, and as I take my dial, you can see here that I'm going clockwise, so there's 1, and it counts 1. Then I go again, and there's my 1, it's on, and then as soon as B comes on, it counts 2. So you see I have to go very slow in order to actually see it on my screen. And there's a third one, there's B, counts 3. So now let's go backwards, and we'll have B on, then A comes on, there's 2, and there's 1. So exactly as we expected. And the idea behind an actual rotary encoder knob is that without looking at it, I can set a position and a rate in which I can turn my knob. So this frees up an operator and gives an operator an easy way of inputting data into the PLC without a lot of expense. So here we go. We'll try going all the way up to 200. So we've done our 10 turns just about, and you can see that we actually stay on 200 no matter if I keep on going. Now if I go backwards, I can then go back down, and you can see I can change the rate of speed at which I'm going up or down. If I click on it or hold the button in, it actually zeroes it out as expected. So, all the links and documentation can be found on our website at accautomation.ca. If you like this video and like to see more, there are 3 ways in which you can help us out. You can give us a thumbs up so other people can find this information just as you have. You can subscribe to our YouTube channel. You can also go to ACC Automation and subscribe to our website. When you do, notification will be given to you every time we publish new content to the site. You'll also get 2 free ebooks on numbering systems and robust data logging. And the third thing to do to help us out is to tell a friend or colleague about the site. Alright, that's it for now. Thanks for watching.